All right, hello and welcome for our test 2 review. Our exam 2 is going to look a lot like our exam 1, but also a little bit different. So your exam will be available from today noon and you'll have a week to complete it. I always try to give you a week to complete all of your work because I don't know what your day-to-day looks like. Also don't know what your workload is or your class load or what's going on in your life. So I try to be super fair. Okay, so this is a review for your test 2. These questions closely resemble those that you'll encounter in your test 2, and your test 2 will be made up 2 parts. You first have multiple choice. The multiple choice option will be on my lab and mastering, just where you complete your homework. There are 20 multiple choice questions, and you have 3 hours to complete them. And you also have 2 attempts. I like to give you 2, just in case you have a bad turn, you can have another try. Now, what's different this time around is that I have an open response portion. This will be 5 open response questions. You have to complete them and show all of your work. And then once you're done, you upload all of your work as a PDF file and you have 90 minutes to complete this portion. So what I'm thinking about, my thought process is that you have an hour to complete the questions and then I give you half an hour to upload them. Now, I understand it might not take half an hour to upload your work, but in case you have some internet issues or it's being slow or I don't know, I know those stuff happens and I have off days where my internet is just not cooperating. So I give you an hour and a half. If you have some bugs or some issues, just email me. It's not a big deal. All right, so you have a review that I'm going to go over with today. And notice that this review is 20 questions. Just like your exam multiple choice, that's 20 questions. So yeah, this is your multiple choice exam. The only difference is I'm not giving you multiple choice. Well, actually, it's not multiple choice. It's just computer. So I guess I should change that. It's just on my math lab. It's not multiple choice. It's like your homework. You have to enter it in. So bad word choice on my end. I'll change that. It's just on my math lab. Now, what's different about my math lab is that it's graded automatically. Rather than the open response, I have to grade it, and it might take me a while to get back to you, like a week or so. Okay, so let's go over these problems. First, we have solve the given system by the substitution method. All right, so substitution method means I want to solve for a variable. You can solve for X or for Y first. It doesn't matter which one. What is nice to do is look for one that it's by itself. It makes it easier. I see Y, it's by itself. So let's go ahead and take that equation and solve for Y. So that I have 5x plus y equals 17. And we said we're going to solve for y. Okay, to get y by itself, I need to move that 5x. So minus 5x, that gives me 0, minus 5x. So that I have y equals 17 minus 5x. All right, that was my first equation. Now I'm going to take that and plug it into my other equation. So I'm going to take my other equation, which was 4x minus 3y equals 6. And I'm going to go ahead and plug all of this in for my equation, for my variable y. Okay, let's go ahead and do that. So that I have 4x minus 3 times 17 minus 5x equals 6. From there, we solve. Notice that we no longer have any y's. They're all x's. Okay, now we need to distribute that negative 3 so that I have 4x minus 17 times 3, 51. And then a negative times a negative, negative 3 times negative 5x, positive 15x. All right, from there I combine like terms. I can add 4x and 15x to get 19x minus 51 equals 6. All right, I add 51 to both sides. So I get 19x is equal to 6 plus 51 is 57. Lastly, I divided by 19. I hope this is a whole number. 57 divided by 19 gives me 3. Ooh, good call. All right, so I have 3x. Now go ahead and take my 3 and plug it into my first one, that one we have here highlighted. So that I have y is equal to 17 minus 5 times, and now my x is 3. That's what we just found, right? That our x is 3. Okay, so we work that out. Y is equal to 17 minus 5 times 3, 15. 17 minus 15 gives me 2. So y is equal to 2. So those are our 2 answers. Now the way you're supposed to enter it is as a coordinate point. Remember, it's always x comma y. So our answer is 3 comma 2. That's what we should enter. Okay, on to the next one. Solve the system by substitution. Now what's nice about this one is, if you notice, this x is already by itself. So it's kind of, that first step is kind of done for us already. So that we have x plus 4 times y equals 5. And now we're going to let x be that whole thing, 8 minus 4y. So that I have 8 minus 4y plus 4y equals 5. Okay, we are just adding, so we can drop those parentheses. So I have 8 minus 4y plus 4y equals 5. We notice that those 4 y's add to make 0. If I have 4 apples, I take away 4 apples, I have no apples. So we're left with 8 is equal to 5. Is that a true statement? 8 is not the same as 5. Think of it as money. $8 is not $5. So we have a false statement. Remember, whenever you have a false statement, your answer is no solution. That's our answer for our second. Now, for any of these problems, that's always an option. Aside from getting a specific point, you can also get no solution, or if you have a true statement, the same number equals itself, then you have infinitely many. Next, we have solve the system by elimination. Elimination means I can add them to make 0. So I can create and add it to 0. Now, to create and add it to 0 means I want the same number opposite sign. Like 4 minus 4 is 0, and negative 4 plus 4 is equal to 0. Notice they're same numbers but different signs. So from here, I want to take a look at my A's and my B's and see if any of them add to make 0. In this case, none of them do. But I can multiply, because I have an equal sign, we can multiply it to the entire equation and change it to what we want. So those A's catch my eye. I see a 4A and an A. So if I take my second equation and I multiply it by a negative 4, that would create that negative 4 I want there. So let's go ahead and do that. Let's multiply in a negative 4 for each term. And I always draw those arrows because otherwise I won't multiply to all of them. I'll make a mistake. Okay, so let's see what we have. We have 4A plus B is equal to 20. And then we multiply in that negative 4 so that I have negative 4A. 4 times 4 gives me negative 16B. And negative 10 times negative 4 gives me 40. And notice how I work really slow. I always work really slow, especially for tests, because we don't want to make a silly mistake. All right, so we see that those add to make 0. That's what we wanted. 4A minus 4A is 0. We're left with B minus 16B. That gives us negative 15b. And we're left with 20 plus 40, that gives us 60. All right, 60 divided by 15 gives us 4. We're dividing by negative 15. So b is equal to negative 4. That's our first part. We want to point. If you're given letters other than X and Y, it's always by order of the alphabet. So A comes before B. So for my answer, I need A comma B. Okay, so now we need to find A. We're going to take our answer and we're going to plug it into our equation. Which one? We have 2. It doesn't matter. You can plug it back into any one, whichever one you think is easiest. I'll go ahead and plug it into the first one. So that first equation was 4a plus b equals 20. Now we have that b is negative 4. So let's go ahead and work that out. So I have 4a plus negative 4 equals 20. All right, plus 4, 4a is equal to 24. Divided by 4, a is 6. Okay, now remember, you want to answer as a point, a comma b. So our answer is 6 comma negative 4. Okay, next we have another elimination method. What makes this one different is we have decimals. Luckily, because we have an equation, decimals, we can work them out. To get rid of decimals, want to multiply by their highest position. So here you have your tenths, your hundredths, your thousandths. Each time you multiply by 10 to get to the next one. So because we have 1, 2 as our highest place, we're going to multiply all of these by hundredths or 100. Now, if you don't trust what I'm saying, you can go ahead and punch each one of these numbers in your calculator and multiply it by 100 and you'll get the same answer. But what it does is it actually moves your decimal point to the right too. And that way I don't have decimals, which look ugly, right? So let's redo our problem. Let's move each decimal point to the right too. So I now have 5x plus, we move it over to 25y. We move this one over to 9900, so 9,900. For our second one, move it over to the right too. We have 15x. Move it over to the right too, plus 5y. Move it over to the right too, equals 108,000. So 10,800. Now we have bigger numbers, but at least we don't have decimals. So that's a thought process for that. Okay, so we want to eliminate using, we want to solve using elimination. So I'm looking at my x's and my y's, and I think which ones do I want to add to make 0? Or see if they already add to make 0. X's catch my eye. So let's go ahead and multiply our first equation by, well, if I have 5 and 15, I'm looking at this 5 and this 15. How can I make that 5 a negative 15? We multiply it by negative 3, right? So let's go ahead and do that. So that we have, now I need to show those arrows for me so that I don't forget to do it. So 5 times negative 3 is 15x. 25 times negative 3, I think quarters, so negative 75y. And then 9,900, 9,900 times negative 3, that's negative 29700. And yes, I used a calculator for this. And then we have our second equation, which is, oh, I forgot that negative on the beginning, which is 15x plus 5y equals 10800. Okay, we get our desired value where our x's add to make 0. Now we're left with negative 75 plus 5y. We get negative 70y. And negative 29700 plus 10800, that gives us negative 18900. Can we divide that by a negative 70? Yeah. And our answer is 270. So we have our y. You can put a star, a check mark, box it, since that is part of your answer. Okay, now let's go ahead and plug it back into our equation. Which one? It doesn't matter. Now, for my equations, I'm looking at the ones with whole numbers. I want to ignore that those decimals ever existed. Okay, let's plug it into one of our equations. I'm going to pick that second one just because my y is a smaller number. So that I have 15x plus 5y is equal to 10800. And now we let our y equal 270. So let's make that happen. We have 15x plus 5 times y, my y is 270, equals 10800. Okay, 5 times 270 is 1350. Okay, we subtract that 1350. Let's use our calculator. 10800 minus 1350, 9450, 5x. Now we divide both sides by 15. So I have x is equal to, divided by 15, we get 630. So what is our answer? Remember, we always want x comma y. So our answer is 630 comma 270. That's what we want to box. Now, what made this question different was those decimals. But we know how to work with those decimals. All we do is go ahead and move that decimal point over. Next question. I have a word problem. An office supply store recently sold a black pricing in cartridge for $14.99 and a color printer in cartridge. I think I meant ink cartridge, but it autocorrected. Ink cartridge for $22.99. At start of recent fall semester, a total of 46 of these cartridges were sold for a total of $793.54. How many of these type were purchased? Okay, so let's first label the numbers or the values. We're working with ink cartridges. We have black in color. So let B be black cartridges, black ink, and let's see B color ink cartridges. Now we want to create a system. It seems like we're working with two things. We're working with numbers and we're also working with a price. So we're working with the numbers, the total sold, and the pricing. For the total amount of ink cartridges sold, the only piece we have is that we sold a total of 46. Now, do we know how many of each there were? No, we don't know anything about them. I just know that black plus color equals 46. So let's write an equation for that. Black plus color is 46. So B plus C equals 46. And let me write it right here so that I can give myself room to solve it afterwards. And we know the pricing. We know the pricing for black was $14.99. And I know the price for color was $22.99. And I know the total pricing, the total sales was $793.54. So let's write an equation with that information. So if I have $14.99 of the B plus $22.99 of the color, my total is $793.54. Okay, we now have our two system of equation. We've done it. We did probably the hardest part. Now we just need to go ahead and solve it like we usually do. So let's continue over here. Now these decimals, I'm going to multiply by 100 so that I can move them over twice. Okay, so we have B plus C equals 46, and 1499B plus 2299C equals 793.54. Let's go ahead and solve. You can solve any method. I like elimination. It's not so bad. Okay, so what I'm going to do is I'm going to multiply that first one by negative 1499. So I can make my B's cancel. So that I have negative 1499 minus 14, forgot the B minus 1499C times 46 and negative 1499. I need a calculator. 46 times 1499. That gives me negative 68954. Okay, and my second equation is 1499B plus 2299C equals, I forgot to move the decimal over, so let me erase that decimal point. 79354. Negative 1499 plus 2299, that gives me 800C. And negative 68954 plus 79354, that gives me 10400. So let's divide by 80 or 800. And we get C is equal to 13. So we know they sold 13 ink cartridges. Okay, we found one of them. To find the other point, I just plug it into my equation. Now looking at your two equations, which one looks easiest to work with? That B plus C, right? So we take that B plus C equals 46 and plug in that C is 13. So we have B plus 13 equals 46. We subtract 13, B is equal to 46 minus 13, 33. So our answer is we sold 33 black ink cartridges and 13 colored ink cartridges. That's our answer. Alrighty, now on to number 6. For number 6, we're asked to solve, and here we have 3 systems of linear equation. I have 3 equations and 3 variables. Okay, So your goal for this one is you want to eliminate the same variable twice. And it doesn't matter which one it is, as long as you do it the same. So I'm looking at this, and I think x's would be easy to work with because I have a lot of x's where there's no coefficient. Plus, I have two x's done straight off the bat, right? With equations 1 and 3. Okay, so we're gonna take equations 1 and 3, and then any other two equations other than 2 and 3. Okay, so we have, I'm sorry, other than 1 and 3. We have equation 1 and 3, and we're going to eliminate x. And then you want to repeat the process, and you want to take two equations and eliminate x again. So far we're starting off with 1 and 3. Okay, so for 1 and 3, they add up to make 0, those x's, right? But let's show that work. X plus y plus z is equal to 6, and negative x plus 7y minus 3z is equal to 2. Okay, let's add them up. Our x's add to make 0, and we're left with 1 plus 7 is 8y minus 2z is equal to 6 plus 2. That gives me 8. Okay, so I'm going to write out my two equations, and my first one is 8y minus 2z is equal to 8. Now I want to eliminate x again, and I want to use two equations. I can't use 1 and 3, but I can use any other two equation combo. So how about 2 and 1? Or maybe 2 and 3? Doesn't matter. Let's go with 2 and 1, 1 and 2. So 1 and 2. Now I need to multiply equation 1 by a negative 2 so that my x's add to be 0. So if I multiply by a negative 2, I get negative 2x minus 2y minus 2z minus 2z is equal to negative 12. And my second equation is 2x plus 4y plus 2z is equal to 14. Okay, let's add them up. Negative 2x plus 2x, that makes 0. And we're left with negative 2 plus 4, 2y, negative 2z plus 2z, that gives me 0z, so my z is gone. And we're left with negative 12 plus 14, that is 2. So far we have 2y is equal to 2. So I'm going to forget that I ever had that beginning part to begin with and just work with those two equations and solve. Now this one's not so bad. I can go ahead and start with equation 2 to get y. 2y is equal to 2, divide by 2, divide by 2, y is equal to 1. We have one of them done. Let's plug it back into our first equation so we can get a z. So I have 8y minus 2z is equal to 8. And now we're going to let y equal 1. So that we have 8 times 1 minus 2 times z equals 8. 8 minus 2z is equal to 8, minus 8 minus 8. Negative 2z is equal to 0, divided by 2, divided by 2. Z is equal to 0. Okay, now that we're done solving for those two equations, now I take a look back at my starting equations. And I want to pick one equation and plug in a y of 1 and the z of 0. Let's use that first equation. So for my first equation, we have x plus y plus z is equal to 6. And now we're going to let y equal 1, and we're going to let z equal 0. Okay, let's go ahead and plug in these values. So I have x plus my y is 1 and my z is 0, and we get 6. So let's go ahead and move that 1. Well, 1 plus 0 is 1. So remove that 1, we get x is equal to 5. And we have our answer. Now our answer always needs to be as 3 points. So my answer is an x of 5, comma, a y of 1, comma, a z of 0. All right, that's chapter 3. That's all we did for chapter 3. Moving on to chapter 4. So chapter 3 is harder, and I think it's a lot more work. I consider to be chapter 4 way more important. You see that so much. So multiplying, factoring, FOILing, adding, combining like terms with polynomials and working with polynomials never goes away. You see it in college algebra. You see it in calculus. You see it in all these math classes. It's so important for you to be familiar with that. Okay, so let's start off with number 7. We want to multiply that monomial into a binomial. Now, monomial just means one term. Binomial means 2. 3 terms is a trinomial, and anything higher than that classifies as a polynomial, but all of the smaller ones are also polynomials as well. So you can just call everything a polynomial and you'll be correct. All right, so let's go ahead and multiply and we distribute. So we want to go ahead and multiply it into everything in the parentheses. So that we have 3 times 7 is 21. We have 21z. 3z times a negative, or positive times a negative is a negative. 3z times 1x is 3xz. And that was it. All right, number 8. And we want to multiply 2 binomials so we have to FOIL. So I have to multiply my first, my outer, and then my inner, and my last. That's FOILing. There are different methods other than FOILing. You can do whichever one you like. In your notes, I showed 2 other methods. The box method and that straight, that linear multiplication way that you've been multiplying since like 3rd grade. Okay, so we have b squared times v squared. And so that's the first arrow. And then we have b squared times negative 2t. So positive times a negative is a negative. B squared times 2t squared. And then we have a negative times a negative, which is a negative. 3t squared times v squared. And then lastly, we have a negative times a negative, so it's positive. 3t squared times 2t squared. Notice that I set up what sign we're going to have before we multiply. And yeah, you can multiply in your head. I just wanted to show all the work. Okay, so v squared times v squared, when they have the same variable, we just add the exponents. So I have v to the 4th power minus, and here all I can do is write them together since there isn't any like terms to work with or to multiply in. So I have 2v squared t squared. If you wrote t squared before v squared, that's fine. As long as they're multiplying order, doesn't matter. Minus 3t squared v squared plus 3 t squared t squared. Oh, t squared times t squared, we add those exponents, we get t to the 4th power. And then you combine like terms. Do we have any terms where they have the same variable? So like terms have the same variable or variables with the same exponents. Do we have any of that? And we do. We have that t squared b squared. I know some of you might think, oh, but they're in different order, but they're still the same variable with the same exponent. So because of that, they class, if we were to switch the order, that would be the same, right? So, and multiplication has no order. That's that's why we can consider them to be like terms. So our final answer would be v squared, and then negative 2 minus 3 minus 5 v squared t squared plus 3t to the fourth. Okay, we're asked to multiply another binomial. And I'll show you a different method. So that first one was called the FOIL method. F for first, O for outer, I for inner, and L for last. You can also do the box method. I like the box method when we have a lot of numbers other than a binomial times a binomial. But I will show you box method in case you like it. So box method says each side gets its own term. So we have b plus 7. I'll write a b and a 7. They're both positive, so I can write them as positive. And I have a b and an 8. So what we're going to do is we're going to multiply each side. So my first side is a b times a b, gives me a b squared. Then I have 7 times a b, gives me 7b. Then I have 8 times a b, 8b. And then 8 times 7 gives me 56. Yeah. Okay, now I just add up my points. So I have b squared plus 8b plus 7b plus 56. I see that I can add up that 8 and that 7. So I'm left with b squared plus 13b plus 56. So this was the box method. Both work for multiplying polynomials. It just depends which one you like the most and which one you decide to practice and work with. Okay, number 10. So for number 10, you're asked to multiply x to the 7th power plus 1 squared. So we know that we don't square each one. There's a meme that says every time you do that, a puppy dies. And I need to put it into our page because I think that applies to us. It doesn't. That means that we're multiplying it by itself twice. So I have x to the 7th power plus 1 and x to the 7th power plus 1, and I need to multiply them. You can FOIL. You can use the box method. You can do all of those. But you can also use a special product. And I believe that's section 4.6, I believe. So if you do any of those, that's fine. But according to our section 4.6, it says that if I have a square of a binomial, like we do here, what we can do is take that rule that says if I have an A and a B, who they're being squared like we have here, I can take that first term squared plus 2 times my A times my B plus my B squared. And that's what you can do here. We can let A be 7 and we can let B be 1. So if we do that, we get 7 squared, x to the 7th power squared, plus 2 times x to the 7th power times 1 plus 1 squared. And that saves the trouble of FOILing. So our answer is x to the 7th power squared, they multiply, so I get x to the 14th power plus 2 times x to the 7th power plus 1. That's our answer. If you don't like this, you can FOIL. That's fine. You can FOIL on your own work. Okay, next question. Factor out a negative coefficient. All right, so it's asking me to factor a negative, but I see that I can factor more than just a negative. I can factor, well, I look at all these numbers and I think, is there a number that divides into all of these? Yeah, we see they can all be divided by a 5. So let's go ahead and divide out a negative and also a 5. And what we see what we get back in return. Now, if it's helpful, you can actually write down your division and divide each one by that number. So if I divide by a negative 5, by a negative 5, by a negative 5, what do we get in return? Well, negative 5 divided by negative 5 just leaves me with that b cubed. 10 and 5, well, they divide to make 2, and I still have that negative, so I have negative 2b. And then 20 and 5, well, the negatives are gone. Okay, number 12. Write an equivalent expression by factoring a cubed minus 3a squared plus 8a minus 24. Well, I'm looking at these and I can't factor a common factor, right? If I look at just this, I can't factor out an a. I can't factor out a 3 or a 2. So what can we do? Because we have 4 terms, and only because we have 4 terms, a method of factoring we can continue with is by grouping. So I can group my first 2 terms and group my last 2 terms. And hopefully I get the same thing in the parentheses. So let's go ahead and do that. So if I divide an a squared, that divides into both of them. I'm left with a minus 3, right? Because I divide each one by a squared. If I take my last 2 and I divide out an 8, because the 8 divides into both of them, I'm left with a minus 3, right? I divide out an 8. And notice that we have the same thing in the parentheses. So what we can actually do is factor out that a minus 3. Or if that seems kind of weird, I just say you can rewrite it. You can rewrite it so that you have what you have in your parentheses, a minus 3, and what you have left over, a squared and a positive 8. And that's our answer. We have factored. Now I'll come back to this one. Let me see what else we have. Yeah, I'll come back to this one because we can potentially factor a bit more, but I want us to see it first. Okay, next we have problem number 13. We're asked to factor 42b plus b squared minus b cubed. Okay, to begin, let's go ahead and write it in standard position, meaning they're in descending order. So we have b cubed plus v squared plus 42b. Is there a common factor that we can factor out? Yeah, we can divide out a v. So we have v squared plus b plus 42. Okay, from there, we try to see if we can factor anything more. We have a trinomial, and I see that I can be factorable. Now, To factor a trinomial where our leading coefficient is 1, I want numbers that multiply to give you your C term, but add to give you your B term. So I want numbers that multiply to give me 42, but add to give me 1. 7 and 2 multiply to give me 42, but their difference is not 1. Did I write this incorrectly? I did, didn't I? We had a negative b cubed. We had a negative b cubed. So let's factor out a negative b so that this is now negative. Let me go back. Okay, let's factor out a negative b. If I factor out a negative b, I end up with b squared, and then there's a sign change for all of these. Minus b minus 42. Okay, now we can factor. What numbers multiply to give me negative 42, but add to give me negative 1? Now I can think of 7 and 2. 7 and 6, not 2. 7 and 6. 7 times 6 is 42, but I need to make one of them negative. Let's make that 7 negative, so when I add them, I get negative 1 in return. Okay, so this factors to be, this part right here is b minus 7 and b plus 6. And that negative b is still there. So that would be our full answer. Okay, number 14. Same idea. Because my leading coefficient is a 1 and I have a trinomial with a square, I want to think what numbers multiply to give me 48, but add to give me 14. 6 and 8. 6 times 8 is 48, and 6 plus 8 is 14. So that means 6 and 8 will do the work. Because I have a v squared, this factors to be a v and a v. So I have v plus 6 and v plus 8. And that is our answer. Okay, next one. Now 15 and 16, well, more 15. The 15 is different because my leading coefficient is not 1. That's a big difference. To continue, I need to use the AC method of factoring. And this is section 4. I believe 4.5. Okay, so for section 4.5, we learned that multiply, you have to label them A, B, and C. You do the same thought process. You want numbers that multiply to give you A times C, but add to give you B. So what numbers? All right, so A times C is 5 times 17. 5 times negative 17, which gives us negative 85. And I want numbers that to give us B, which is negative 17. Okay, well, this one's tougher because I have to think, well, how can I get 17 from 85? Well, let's make a list. Well, I know 85 times 1 works, but that won't help us out. Maybe divided by 3. If I divide it by 5, I have 5 times 17 is 85, but that won't work. What if I divide it by I'm just testing out numbers to see what works. I can't seem to come up with one. I think this one's prime. Okay. There's no such numbers that would multiply give us 85 and not to give us 17. Okay, 16. Factor w squared minus 9w plus 8. All right, so what numbers that multiply give me 8, that add to give me negative 9? So I know 8 times 1 is 8. And if I make them both negative, negative 8 times negative 1 is 8. And negative 8 plus negative 1 is negative 9. So that works. W minus 8 and W minus 1. $17. Factorial trinomial. Okay, hopefully this one works out. So I want to multiply, because my A is not 1, I need to multiply my A and my C. And I want those factors to add to give you your B. So if you want to, you can label them. You have A, B, and C. So A times C, 2 times 9 is 18. And my middle term is negative 9. So what numbers can I multiply get 18 and add to get 9? Well, I know 6 times 3 is 18. And if I make them both negative, then they multiply, give me positive 18, and add to give me negative 9. So what we're going to do now is replace that middle one by negative 6 and negative 3. So that I have 2s squared minus 9s, not plus 9s. We're going to replace it with 6 and 3. Negative 6s minus 3s plus 9. So then I group my first two and my last two. Okay, for my first two, well, we proceed by factoring by grouping. This is factoring by grouping. We saw this before. So let's divide out that s, 2s from those first ones. So I have 2s, that just gives me s minus 3. Then I can factor out a negative 3 from the last two, so that I have s minus 3. And we see we have the same thing in the parentheses. This factors to be s minus 3 times 2s minus 3. And that's how we factor when our leading coefficient is not 1. Okay, let's continue with 18. So we're asked to factor 3ad to the 4th power minus 3ak to the 4th power. Okay, let's begin by factoring out a common factor. So I see I can factor out the 3 and the a. If I factor out a 3a, I'm left with d to the 4th power minus k to the 4th power. Okay, now when we have a minus and my two numbers are squares, are numbers I can raise to the 2nd power, then I have differences of squares. So I want to think d to what power squared gives me d to the 4th power. So we essentially divide by 2. 4 divided by 2 is d squared. Same thing for k. Now, when we have differences of squares, we're going to take those numbers and I'm going to multiply them by each other. I'm going to write them up so that one's a minus and one's a plus. So I have d squared and k squared and d squared and k squared. That's factoring by differences of squares. And of course, you still need to bring down when you factor in the beginning. We have fully factored this problem. This is a special case of factoring. I think this is section 4.6. I think I'll go back on this review and write down where each section's from. That way you can refer back to it in case it's something you want to see more of. All right, for 19, we have a third power, right? Whenever I have something that can be divided by 3, we have differences or sum of cubes. In this case, I have sum of cubes. Sum of cubes is defined as I have something to the third power plus something to the third power. To factor it, it factors to be those same numbers. And then we create a trinomial. And this trinomial is prime. It's a squared minus a times b plus b squared. And yes, I know I have a plus, but this right here is a minus. And that's your formula. You find these formulas in section 4.6. Okay, now what I need to do is think of these numbers as something to the third power. Let's start with 125. I know 5 times 5 times 5 is 125. So I'll do 5. Now 64. 4 times 4 times 4 is 64. So I'll write a 4. And that x, I divided by 3, so it just gives me 1x. This will be my a, and this will be my b, so that I can use my equation that I have on the right. So by my equation, this gives me 4x plus 5. And then I'm going to take my a and square it. So I have 4x, I'm going to square it, minus those two multiplied, 4x times 5, plus my last term multiplied by itself, squared. Now let's clean this up. So I have 4x plus 5. That square applies to each one. So I have 16x squared minus 4 times 5 is 20, 20x, and 5 squared is 25. There we have it. This was a sum of cubes. Okay, 20. Let's go ahead and factor completely. Now we have a trinomial and I see they're both, all these numbers are even. So let's start off by factoring out a 2. Let's divide each number by 2. So 2r squared divided by 2 is r squared. 24r divided by 2 is minus 12r. And 72 divided by 2 is 36. Okay, now we see that here we have a trinomial. Can we factor it? Well, let's see. Can I think of numbers that multiply to give me 36 but add to give me negative 12? 6 and 6 works, right? Negative 6 and negative 6. So this factors to be r minus 6 and r minus 6. Whenever you have something times itself, you want to write it as an exponent. So because we have 2 copies, this would be r minus 6 squared. And don't forget that 2 you factor in the beginning. So there we have that problem. Now, there was a problem in the beginning of chapter 4 stuff where I asked that we hold on to it because we can factor it a bit more. So let's go back. I think that was problem 11. Problem 12. Okay, so that 2a plus that a squared plus 8, I thought it was a cubic. I don't know why. So I thought we can factor it further. Now I see that's a square. So we can't factor it further. That's our answer. So I can go ahead and erase the star. I thought it looked something like 19, but that's not the case. I will have to have an exponent that can be divided by 3. There, I just had a square. Okay, so that was your review. Your test 2 will be 2 parts. You have 1 part in my math lab where you have 2 attempts and you have 3 hours to complete it. And then an open response part where I want to see your work for it. There'll be 5 questions. I think it's safe to anticipate there'll be a lot of factoring. That's my big hint. I worry so much that you come out of my class being great factors because you'll see that a lot. That's my hint. Expect a lot of factoring. But it's not so bad. If you practice it, if you do your homework, you have enough practice so that you can do this test. So what's my biggest advice for you so that you can do well on your test? Do all of your homework. Homework is the most important thing you can do because that's when you practice it. So once you've done all your homework and you feel confident about what you know, then I want you to go back and do this review. Maybe watch the video, but try doing it on your own, at least one shot completely correct. And if my biggest advice is do it once and do it more than once. Because sometimes when we do it the first time, we're iffy, but then you do it the second time, you're like, okay, I got this, I'll remember this, we're fine. And then go ahead and take your test. If you do that, I think you'll be in good shape. You'll get a really good score. You'll be happy about what you got. All right. Are there any questions before we? Well, that's it for our Zoom meeting. Let me stop the recording.